So this video is just a quick introduction to what you're going to be doing in the Unbalanced Torque Lab. So first thing, there are a total of 5 different bicycle wheels available in this Pivot Interactive activity. And I want to spread out the class across those 5 wheels. And so there's a sign up on Schoology that you're going to use to pick which wheel you'll collect data for. And then you'll just answer this multiple choice question to let me know which one you collected data for. And then all the data is going to come from this video. If you click the drop down here, you can choose the wheel you signed up for. You can also choose how much hanging mass is attached to that wheel. And remember, you'll need to hit go once you've selected the options to select the correct video. Now, we're looking for a relationship between torque and angular acceleration in this lab. So the amount of torque that's applied to this bicycle wheel and the angular acceleration of the bicycle wheel. Now, torque is something that's really hard to measure directly, but they are applying a torque. They have a string that's wrapped around each wheel, and then they're putting different hanging masses on the end of that string. So what I would do as a first step is sketch an extended free body diagram of your wheel. And so you're going to show your wheel. That's a really terrible circle. I'm sorry about that. Your axis of rotation will be right in the middle. And then that hanging mass is going to apply a tension force to the wheel right at that point where the string pulls off of the wheel. And so you can use that along with what you know about torque from last week to figure out how much torque is this force applying to the wheel. The other quantity you're going to have to deal with is angular acceleration. So along with being able to see how much mass is attached to this string by looking at this number here, you do have a ruler that you can use to measure things like the radius. You also have a stopwatch, and you have a protractor. This protractor doesn't have the angles labeled, but like from here to here is going to be 90 degrees or pi over 2 radians. Here to here is going to be pi radians, and so on. And I should point out, you can rotate this protractor to get those angles where you'd like them to be. And then most of these wheels do have a dot or something similar that you can use as a point to follow. Now, the angular acceleration is also something you're going to have to calculate. So you'll be able to measure time and angle. What I would do is go to your formula sheet and look for these equations right here that we got in the AMM1 module, and look for one of these that you can put in quantities that you can measure to relate angle, time, and angular acceleration. And keep in mind that the initial velocity is 0 if you start collecting data right as the wheel starts moving. The other thing I should make sure to point out for data collection is that this constant unbalanced torque is only applied from the time that this ribbon is cut. So at the very beginning of this video, there are balanced torques on this wheel. Because it's at rest, it's not it doesn't have any angular acceleration. And then it's not until this ribbon is cut that there is an unbalanced torque that's going to cause an angular acceleration. And so make sure you're not collecting any data while that ribbon is intact. And then similarly, because the torque comes from the force of tension applied by this string, once that hanging mass hits the table, that string loses its tension, and the torque on the wheel changes. So you only want to collect data from the time that the ribbon is cut to the time that that hanging mass hits the table. I also want to remind you, you can use calculated columns. And so if it's easier for you to just type in how much hanging mass there is and then have a calculated column to find the torque for you, go for it. You can do the same thing with angle and time, and then have a calculated column to find angular acceleration. Your graph should have torque on the vertical and angular acceleration on the horizontal. And then there are a few questions for you to answer based on your graph, and you'll be posting your graph and your equation to a discussion board on Schoology.